questions. First part, it says if cosine theta is negative 3/5, right, as soon as you see the fact that cosine is a negative, you know you have to be in the second or third quadrant, because remember, cosine is an x value. And then it says sine is greater than 0. So this tells us we have to be in the second quadrant. Cosine is negative, sine is positive. That's the second quadrant. And now let's look back at the original statement. Cosine of theta is negative 3/5. Let's go ahead and draw the triangle that corresponds to a cosine of negative 3/5. So I drew left and then a hypotenuse of 5. I can use the Pythagorean theorem to find me that this height here must be 4. Remember, a 3, 4, 5 triangle. And then once I know this side is 4, then I can do sine of theta. Sine of theta is opposite over hypotenuse, and then I can get sine of theta is 4/5. A lot of these are going to be similar. Tangent is negative. All right, we know tangent is negative in the second and fourth quadrant. Right, so we know it's in the second or fourth quadrant. And then let's just go ahead and draw a triangle. So we know this radical 3 is going to involve the 30, 60, 90 triangle. So 1, radical 3, 2. And if you're doing tangent and you're getting radical 3, you must be doing radical 3 over 1. If you're doing radical 3 over 1, that angle is the 60-degree angle. So we know that the reference angle has to be 60 degrees. But since tangent is negative, we have to be in the second or fourth quadrant, and then that figures out that we have to be then 120 or 300. Think about it. 120 and 300 both have reference angles of 60. They're in the second and fourth quadrant, so that's when tangent is negative, and tangent of 60 is radical 3. And so these are the only two angles that work. Very similar over here. Cosine of negative radical 2 over 2. Well, think about a 45, 45, 90 triangle. Cosine of 1 over radical 2. Again, 1 over radical 2 is radical 2 over 2. However, we want cosine to be negative. So we know we have a reference angle of 45, but we need cosine to be negative. So then we have to be in the second and third quadrant. So what angles in the second and third quadrant have a reference angle of 45? Well, we got 3/4 pi and 5/4 pi. Those are in the second and third quadrant. That's where cosine is negative, and cosine of 45 degrees is radical 2 over 2. Okay, sine of theta is negative 1/2. Just focus on the half. Sine of 1/2 means this angle must be the 30-degree angle. If we're taking sine and we're doing opposite over hypotenuse. So we know the angle is 30 degrees. We know sine is negative. And we know cosine we want to be negative. Well, the only one is then in the third quadrant. Third quadrant has a negative sine and a negative cosine, and we need a reference angle of 30. So that tells us our angle must be 210 degrees. All right, these are just done without a calculator, so just take 750 and go around twice, vroom, vroom, and then you're left with 30. Secant of 30, go ahead and draw your triangle. Secant of 30, secant is hypotenuse over adjacent. So you get 2 over radical 3, which we then write as 2 radical 3 over 3. Cotangent of negative 37 force. Okay, so let's get rid of 32 force. 32 force is 8. If you do 8 pi, vroom, 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 you go around 4 times, so you're back to the normal. And so really we're just doing cotangent of negative 5 force. Negative 5 force, again, negative goes cycle this way. And then negative 5 force pi is 45 degrees in the second quadrant. Cotangent of 45 degrees is just negative 1, right? Tangent of 45 is 1. Cotangent is just going to be the reciprocal. But since you're in the second quadrant, the reciprocal of negative 1 is just negative 1. All right, negative 600. So if we go around 360, and then we have another 240, we end up there. So we end up in the second quadrant with a reference angle of 60, and then cosecant is going to be hypotenuse over opposite. So we do hypotenuse over opposite, and then we do the same thing. 2 over radical 3 is just 2 radical 3 over 3. This is very similar to the first questions. Sine of theta is negative 1/4, and we want cosine if cosine is negative. So if that's negative and that's negative, we're in the third quadrant. So then I just drew the triangle. Opposite is 1, hypotenuse is 4, and then I used the Pythagorean theorem to find out that that side length must be radical 15. And then I did cosine. Cosine is radical 15 over 4, and it's negative because I'm in the third quadrant. This one we've definitely put on test before. You know, we give you some point, point P, 5 comma negative 12. So we're right 5, down 12, and then the hypotenuse is 13. I use the Pythagorean theorem to figure out that 13. That is a triple you probably should know. And then I just did sine, cosine, and tangent, and then I did cosecant, secant, and cotangent. Remember, these guys are just the reciprocals. So just do our normal sine, cosine, and tangent with SOHCAHTOA, and then go ahead and do the reciprocals. Which trig functions are positive in the fourth quadrant? Well, that's just cosine and secant. Remember, if cosine is positive, secant is the reciprocal, so it's still positive. Sine is positive in the first and second. Tangent is positive in the first and third. Cosine is positive in the first and fourth. Remember, cosine is an x value. Sine is a y value. Tangent is a y over an x value, and then go from there. If you want to be secant to be less than 0, meaning secant is negative, or cosine is negative, we got second and third quadrant, right? When x is negative, so left. All right, this one's not on the test for sure, but this is just kind of a preview of this will end up being the Pythagorean theorem identity. Probably the most useful trig identity you know is that it'll end up saying that sine squared plus cosine squared is equal to 1. And I just had you do it for a specific angle. So look at 30 degrees. Sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. And then if you do sine squared, that's just 1/2 squared plus cosine squared, so radical 3 over 2 squared, you get 1/4 plus 3/4, and you get it's equal to 1. And it turns out that that is actually always true for all angles, and it's really just the Pythagorean theorem. Whatever angle you get, if you end up taking the opposite side squared plus the adjacent side squared, you get the hypotenuse squared. And if you're doing for the unit circle, it's always equal to 1. And the last one, which quadrant has cosecant positive? So we need a positive sine value and a negative cotangent, which is the same thing as a negative tangent. So we need a negative tangent and a positive sine. Boom. That's the second quadrant. A positive y value, but a negative y over x value. Okay, take a look at those. They, I think once you kind of get to the hang of some of these by drawing pictures and thinking about quadrant and then thinking about what reference angle, they turn out to be okay. There will be some of these on the test. The only one I'm telling you I won't put on the test is this trig identity, the sine squared, cosine squared stuff. But the rest of them you really should be able to handle. Hopefully this video helped.